Two. Today we'll be taking a look at our final PCB design for our main computer build out, which is our backplane. And before we dive into the PC board design, we're just going to talk a little bit looking at our schematic diagram for our main card edge connections. Because if you recall, we ended our last video talking about some of the issues that we were having to deal with based on decisions we made. And one of those was that the card edge connectors, uh, the bus lines are not all in the same location. We can see that we have, address and data bus here. On this card, we have data bus here, data bus here. We have uh, the left bus here on this card, and then we have the left bus on this side. So we kind of have to rationalize that. I'd like to say, in other words, unspaghetti this. So the first part of our, PCB design work was figuring out how to stack these connectors, right? How to arrange these connectors to to best enable us to do the routing on the card. And so you're kind of looking at the stacking that I came up with. Now, if you look at the memory card here, this is the card that ends up being the pattern for all of our expansion slots. So the expansion slots are going to be, pinned the same way as this is. So it's not depicted here, but our expansion slots are going to appear above the memory card. So the memory card is going to be like our last, primary computer card, and then just the expansion slots will have the same pattern, above. So, but you can see how this kind of like helps us out. So, we have the data lines here. We're going to have to bring them down this way for this card, and then they'll come straight down for this card. Our address lines are going to have to come here and route it over to this side on the memory address register card. Then our data bus lines again are going to be brought down straight down here to the registers card, but the left bus will have to get routed over here, and then we have our right bus, and that will lead into the ALU. So I think our data bus is going to have to switch over to here. Our left bus and right bus will come in. Then right, we have our data bus coming straight down here, coming from the ALU to the controller. And then we have all of our control signals. And then again, for all of our cards, this is the same for all of our cards. So all of our main clock signals are all here, and they're going to run straight up on the PC board design. So that's just kind of the initial groundwork for the PC board design, was just coming up in an approach as a correct stacking for these things to kind of help us do the routing as best we can. Okay, so this gets us over to our PC board design now. Just starting out with the card with the board outline. So the motherboard is going to be 300 millimeters by 400 millimeters. And just to contrast that with our standard card size, we used 200 by 150 millimeters as our standard card size. So this is substantially bigger than that. But the cards will plug in here, and the cards are going to kind of run from like here over to here. Is going to be the footprint for the actual card. Okay, so you can see here we have our card edge connectors all in a row and aligned, and we have our three expansion cards, and oops, we said that the memory card was the last of our main computer cards, and then the expansion card is just going to carry this through. So, but we see here that we have to start threading these buses crisscrossing them to go from one card to the other since the buses are not all in the same location. So you can see here we bring in the address lines. These are coming over, and then on the bottom we can see that our data bus lines are flipping over to the other side. Okay, but you can see that we mainly carrying our data bus lines through on all the cards and threading them down, and the same thing for the left and the left and the right buses. Okay, so we have a left bus here coming down, and then we have our registers card, which is really where we have left and right bus come out of that card, uh, and they are coming into the ALU, right? The ALU uses the left and the right bus plus the data bus. So we see the data bus coming down here, and then the left and the right buses coming down to the ALU. And you can see here also that so here's our left and our right bus pull down resistor networks to pull those down to low signals. And then you can also see here that we have our breakout headers for the left and the right buses. And we're going to use those headers to both, examine the signals on the bus as well as inject signals into the bus for testing. Okay. All right, so we can see we dragging down most of our bus lines. Now, here's our control unit. So this is where all of our control signals come out. Our data bus comes in, is brought into the control unit card, but then all of our control signals come out. Now, you can see those control signals all coming out in red on the top layer. So they're coming out to where? So these are our control signal bus lines, right? And they're running the whole right side of the PC board. So those are there on the board. And again, you can see here the control lines coming out from the controller, being brought out to the control bus lines. And then we have the yellow are the control lines coming in from the control bus to each of the cards as those signals are utilized. So when I was, fleshing out the card design, first thing I did obviously was have the card edge connectors in place, and then I knew that, right, I knew where the issues were, right? I knew where a lot of the signal crossovers between cards was going to occur. So I kind of did that first just to see that I was okay um, with doing the routing. So I proceeded that, went forward with that um, to a certain level, and got to a point where I was kind of satisfied that I wasn't going to get into paint myself into a corner, and then would go on to doing the routing in a different area. So I did, some of these bus crisscrossing, I'll say, between the cards, and I got some of that, I got that done to a reasonable level. And then I was, I wanted to flesh out some of the details of the control lines. So I laid in and created I laid in the bus lines, the main control bus lines that were going to go between cards. And then uh, once that was done, right, then brought out the control lines from the control card to the bus lines. So somewhere along the way in that process, it became evident that I in fact was painted into a corner, and I could not. There's no way I could do the routing with a two-layer PC board, which is what we've been using for all of our other cards. So I in fact had to go to a four layer card for the backplane. So we can see that we have We have our top layer, we have our bottom layer, we have our inner layer one and inner layer two and inner layer two. So that's pretty much what I had to do to be able to get the routing completed. So, most of the bus lines are routed on the top, right? Some of the bus lines are wired on the back plane, and then I have all the main control signal buses are on inner two, and then um, the lines that are bringing the control bus signals to the actual cards are on inner one. So that's how that ended up having to go. I was again, that was something completely new for me, but it wasn't too bad to do that. To do that, it I think I've kind of done this in a reasonable fashion, and I'm using copper pores on each of the planes. So the top pore is VCC, um, inner um, one is ground, and then inner two is VCC, and then the bottom layer is a ground pore again. So that's kind of how the stack up went um, for the PC board design. Okay, so let's go back to our top layer here. So that's kind of how the routing went for each of the card edge connectors and the control bus lines. And you can see here that we have all of our pull up and pull down resistor networks for all of our signals. We have the breakout headers again that we're going to use to both examine the signals as well as inject signals for testing. So this is our uh, pull up, pull downs for our clock signals, and then each of our control line. We already looked at the pull ups and the breakout headers for the left and right bus, and then we have we have our pull ups for our address bus and our data bus, as well as again our breakout headers for those signals. And another additional breakout header that's just to basically pull all of the expansion card signals all out to a convenient header that we can examine in one location. Okay, so that's all of our pull ups and pull downs for our signals. This is our hex digit display. We have our comparator that drives our latch signal for the two TIL 311 hex displays. And then we are bringing up here our data bus up to both the till low and the high, the low and the high, the low and the high digits. And then over here we have our reset circuit, right? Here's our 74LS14, our Schmidt inverter, and that we're using. Here's our reset switch, and here's our reset LED, right? That's being driven from the inverter. And now I've also brought out an additional header here that will allow us to have that external reset button or switch on our enclosure once we build an enclosure. And then we had one extra inverter here on the 74LS14. So I brought out as an indicator, added in an additional indicator, which is the not memory out signal. So this LED will be on when the memory address register is not driving the address lines. So in other words, the address lines are floating when this LED is on. But when we plug in the controller card, uh, this line, which is active low, will go low, and the memory address register will begin driving the address bus. So that was a little addition that I did to late in the design. Here is our power section. We have our barrel plug. We have our resettable fuse. Here's our power indicator. And I also brought out another little uh, 5 volts out header, just as a convenient item that more than likely we're going to use as we're going to need some power for our testing purposes for the backplane. And what else? So these are our mounting holes for our card. So we're going to have, right, it's going to be our mounting hardware is going to go there. And what else? I think that's mostly what we needed to talk about. And I think that's it, right? We have our bypass, our power, decoupling capacitors here. I think we have 3 of those. And I also have some vias, some vias that connect uh, the VCC plane together. Okay, so I think that's everything. Yeah, so this was a complicated board to do. Again, it was the most complicated board, but yeah, that wasn't going to be possible for me to do this with a 2-layer board. So going to that 4-layer board um, really allowed me to, easily complete the design. And we can take a look at a 3D view of our board. Okay. Right, here's our hex display and our reset circuit. Right, our mounting holes for the board. Right, our power section. Our left and right bus. Breakout headers. Right, and finally our breakout headers for our clock signals and all of our control signal breakouts. Okay. And then another thing that just to be aware of is that so here's our card edge connectors. Now the actual circuit board is on the back end, or is on the back end of the connectors here. So there's really nothing from here to here. It's free space. So kind of need to make sure that these items, fall between the gaps, just so we don't, bump into the bottoms of the cards that are plugged in. I think we're okay. We're okay there. And yeah, that's our card. And this is already off to fabrication. And I hopefully will get this card back from fabrication by the Monday following the publishing of this video. So then we'll get right on to starting to populate this board. And then I think our next video is going to be a video kind of discussing my approach for how I'm going to proceed with the build out of this card and with the testing of this card. Because I'll tell you what I'm not going to do. I'm not going to build this all in one shot and just plug in all the boards in and put on the power. We won't be doing that, but in our next video, we'll kind of discuss how that's going to go. So, yeah, getting to be an exciting time in the project. I'm really anxious to fire this thing up and see that it is working, that it's working. So that's it for today. Until next time, thanks for watching.